Okay, today's lesson is called the derivative of exponential functions. So today is June the 7th. Oh, sorry, warm up. Thank you.
Gotta do your warm-up instructions.
But what was it?
Derivative of exponential functions. Sorry, thank you. I should do the warm up. This is right. So the warm up says find dy by dx for 2x squared y plus y cubed equals x plus 14. Now, as you see, you're getting a lot of these questions like this one. You can move up, by the way, and sit in the best place. Because no one's. Sorry, I'd rather. What meant to happen, Teresa, is that you can blame Nathan for this, but this is your seat from now on. Tanner's going to bring you up a desk every single day. Okay. So anyway, can I get a brave soul who wants to give me product rule for the left-hand side? And they can start out. Go ahead. Okay, can I get it, guys, please? Go ahead.
4x.
Yeah.
Y.
Yeah.
Plus 2x squared.
Yeah.
Plus 3y.
Okay, close. Right, because whenever you get rid of a y, that changes dy by dx. Overall, really good though. That's excellent. Okay. All right. Can I get another brave soul to tell me what the root of y cubed is going to be? Chris isn't here, so everyone's got to step up today. Okay. Everyone has to raise their hand a little bit higher. Austin, go.
3y squared.
3y squared.
dy over dx.
Thank you. Okay, and a third brave soul. Give me the right-hand side. Go ahead. 1. Okay. Now, if you were unable to get that, 1 second, Michael, let me just do my spiel that we can do it. If you're unable to get that, please make sure you ask or get things clarified out, because we only have 2 days left of class. Okay, right? It's scary. We're going to cover on Friday. I want to make sure we're good on this. Friday we're going to do word problems. It's probably going to be the recap for the test. And some trade again. Sorry, Michael, go ahead.
So y per y.
Oh, because excuse me. Just back to here, it's hard to see if you're sitting at the back. But again, if you're taking the derivative of y, it's just going to be dy by dx. If you take the derivative of y cubed, as long as, again, the y changes dy over dx. Every time you remove a y, like the y breaks down by 1, it goes dy by dx. So y cubed goes to 3y squared, but because 1y was, you know what I mean, gotten rid of, that changes dy dx. Okay? All right, so we're looking good, but not yet great. Derek, you're looking down this morning. You know what will pick you up? Some math. What's the next step here to solve this question, please?
We need to isolate dy by dx.
Yeah.
Send 4xy to the other side.
Thank you. Sorry, I hope you're really not feeling down. I didn't mean to embarrass you. Sorry.
And he's just looking down.
I'm gonna sit. Yeah.
She just smacked me.
In grade 7, Austin DeVries smacked me in the back of the class, and the teacher saw and did nothing.
She smacked
Okay. Let's calm down here.
You're gonna fight.
This is why I assign seat. Just this is why I give assigned seating plans. There's no fighting on a regular day. You notice that? All right, Nathan. Since you're sitting in the front row today, what do we do now? Let me help you here. We're doing the left-hand side. Awesome.
Isolate dy over dx and then divide it with 2x squared plus 3y squared.
There we go. Are we feeling sort of okay? Let me please do your song. So
What questions I don't
okay. Sorry, I said I was going to do it, but not actively, right? I said I was going to do it. Okay, are we feeling sort of okay mostly with this? James, how you doing? James, I just want to mention I did some coding last night for the first time in about 10 years independently. So it was a big moment in my life last night, just so you know. That was my birthday gift to myself, is that I coded. Okay, yes, and a heat. So. okay? Anyway. All right, let's ready for today's lesson? Let's go. So today's lesson's called the derivative of exponential functions. Okay, this is our last derivative rule of the course. And I did you guys a little bit of a disservice this year, I think, because because of timelines, I haven't made you prove anything, and I'm going to continue for that. So I'm going to say if f of x is equal to b to the x, I think you can see this. No, ln, so it's ln. So it's remember that's natural logarithm. So I don't remember, Bailey, if you were in my class or not when we did that with the money unit. But ln, sorry, 11. So what ln is, just a reminder, it is log base e to the x is equal to ln x. So I mean log base e. If you remember before we talked about e, this is probably going back a week and a half now. Okay. So I want to do a few of these derivatives just to make sure that we're handling them okay. Because these are the questions here, sort of embarrass you again, Hannah. Hannah said she tried these last night, and some she remembered and some she didn't. Okay, it's because we haven't really done this yet, so that's why we'll go through here. Okay, so let's start with some derivatives. So this is the final rule. When you get to university, I apologize. Your professors will make you prove all this stuff. So what they will do is they will spend blackboards of proofs, and I decided not to do that this year because I want you guys to do examples. So I apologize. Tell me next year if that's a detriment to you. Hopefully it's not. Okay. Here we go. Example 1 says find f prime of x. Okay, we haven't really done much of this yet, so I'm going to start right at the basics, right at the fundamental thing here. Okay. So we said the derivative of e to the x is just e to the x. Okay. So what this actually is for the derivative of e to the 3x, this is going to be can somebody be brave and tell me where the heaven that 3 came from? Really, go ahead. Good? I need more important than that. I need a little bit more power than that. Yeah, go ahead. Yeah, this is the derivative of the exponent this is going to be. Okay? Oh, just leave the jokes for right now. Okay, if I say f of x is equal to 3e to the 4x squared plus 5x. Okay, someone other than Tanner to be brave and to try the derivative of this one. All right, Tanner, you're out. I appreciate your volunteer. Go ahead. Okay, how'd you get that?
4x squared and 1 plus 5x.
Whoa. Yes, but you have to come down here. So this is going to change to 8x, right? The derivative of 4x squared would be 8x.
Right, yeah.
Okay, so I'm going to call this, but what you need to remember here, that stays in there, but then it's times whatever the derivative of the exponent is.
So 8 plus 5.
8x plus 5, yeah. Right? So you see that? You sort of feeling okay with this before I move on? Yes, we're good. C. F of x equals 5 to the x. Okay, now this is just straight. Ow. This is just straight out of the definition here that we had in the last page. Can someone be brave and look at the last page, Austin Cool, and tell me the derivative of a number to a power x? What's the derivative of that going to be? Look at the last page. Look at your note. Don't know. What's the derivative of b to the x? What's the derivative of b to the x? No, that's e to the x is like that. E to the x is that. What's b to the x going to be? Teach us any number. Go ahead.
Ln B?
Yeah, ln b. So f prime of x. But that's the 5 to the x is still there. Austin, the 5 to the x is still there. Remember, ln 5 is just a number. You can type that into your calculator and get like a decimal for it, or get a number for it. Michael and then Teresa. Michael, go ahead. No, e is a number. Remember, e was equal to 2.718. Like it's just a. Yeah, it's very much like pi. Log base e is what it is. Sorry, please go ahead. Okay. Yeah. No problem. Okay, are we ready? You guys are inspired? No, yes, you're ready. You're inspired. You can do this. You want one more? You want a hard one?
Yes, extremely good.
Okay. We're up to example D. There's nothing difficult about these, though. How about that? Okay, now that looks terrifying, doesn't it? Now, I haven't really shown you how to do this, that's why it's terrifying. Okay, I'm going to pick on someone at random, that being Alistair. Alistair. Let's pretend that was 3 to the x. What would the derivative of 3 to the x be? Yeah. So f prime of x is going to be ln 3 times 3 to the 4 sine x. Now, the difficult thing is there's still the exponent there. Does someone want to take a guess of what we do with that exponent now? Go ahead.
Same as before, we took the derivative and have it down.
Right on. So this is going to be 4 cos x. And as Tanner said before so eloquently, this is the derivative of the exponent. Okay. Is that sort of making sense here for this? I'm going to get to some awful ones at the end of the lesson. Okay, right? But the whole idea is if there's an exponential, it's going to be ln whatever the base is, but ln of e is just 1, so that cancels. And then times the derivative of the exponent. Michael, go ahead.
So, how come A and B don't have LN?
Oh, okay, because, good question. Because, okay, if I do e to the x, that goes into ln e times e to the x, right? Where ln e is equal to log e to the e times e to the x, which is equal to 1 times e to the x, which is e to the x. Right, that's why e to the x just changed to e to the x, because the log, like the ln of e is just equal to 1. I mean, like that just cancels out. Ln e is just
Whenever there's an E dot, we go that way.
right. Yeah. Sorry, who else had their hand up that I snubbed? No, is that you? No, do your hand up. Yeah. Does this make sense though? Why we get rid of that? Okay, right. It's just e's just going to stay there if it's a 2 or a 5 or 1,000. If it's a 2 or a 5 or 1,000, it goes from that. Okay. Here we go. Let's do some tangents. Example 2. And you guys can try this one and I'll pause the video. Example 2 is going to say, look at this, I can see what time it is. Isn't that nice? Okay, so I'm giving you the standard calculus question. Find the equation of the tangent of the graph. Okay, so this is just the standard, not remedial, it's a better way to put it, but this is like the fundamental calculus question that we have to do. Okay, so any type of equation. If you are looking to study for your final exam and you don't know what to study, make sure for polynomial, exponential, logarithmic we'll get to in a little bit, sinusoidal graphs, rational graphs, you can do this type of question for. Okay, because that's this should be like a standard type. I'm going to pause in the video. I'd like you to try it for me, please.